Disclaimer. This video content is AI generated as educational purposes only and is not a substitute for professional medical advice, diagnosis or treatment. Your health concerns may be unique. Always consult your physician or a qualified healthcare provider for personalized guidance.
Today, we are diving into a hidden network that's running inside all of us right now. It's this fundamental connection between how our bodies use energy and how they fight off disease. And, this connection might just be the key to solving some of the biggest puzzles in modern medicine.
So have you ever stopped to wonder about this? Why is it that these conditions that seem so separate, obesity, type 2 diabetes, heart disease, why do they all share this one really dangerous feature? Chronic inflammation. It's a huge question, and the answer points to a much, much deeper connection inside our bodies.
Well, it turns out the answer lies on a kind of biological superhighway. Think of it as a constant two-way street of communication that connects our metabolic system, that's how we make and use energy, with our immune system, our body's defense force. Getting a handle on this connection is really the key to unlocking this whole mystery.
Okay, so this brings us right to our first section. We're going to explore this two-way street and introduce the official name for it, the Immuno-Metabolic Axis.
So what is it exactly? Well, to put it simply, the Immuno-Metabolic Axis is this back-and-forth relationship. Your immune system's ability to work depends completely on your metabolism for fuel. And at the very same time, your immune system can totally hijack how your body manages its energy. They're in a constant conversation.
And like any great story, this one has a whole cast of characters. You've got the immune cells, our soldiers on the front lines. Then there are the metabolic organs, which are kind of like the fuel depots. We've got signaling molecules. These are the messengers carrying critical orders back and forth. And finally, the nutrient sensors, which are like this intelligence network, always reporting on how much fuel is available.
So why does this axis even exist? Well, it all comes down to survival. When your body's under attack, say from an infection, it has to make some really tough choices about where to send its energy. It's got to prioritize keeping the brain online and fueling the immune army. So it literally reroutes glucose away from storage in your muscles and fat to where it's needed most for the fight.
So let's look at the first direction on this two-way street. In this next section, we'll see exactly how energy fuels the fight, and how your metabolism is really the one calling the shots for your immune system.
This is where we get to this incredible concept called metabolic reprogramming. Think of it like this. An immune cell doesn't just use one kind of fuel, no way. It strategically switches its energy source to change what it does, almost like a soldier picking the exact right weapon for the mission ahead.
Let's just take the macrophage cell as a perfect example. When it needs to be an aggressive attacker, an M1 cell, it switches to glycolysis. That's just fast sugar burning. It gives it this explosive energy to create inflammation. But when the battle is over and it's time for cleanup, it morphs into an M2 repair crew cell. And it does this by switching to a slower, more sustainable fuel, fatty acids, which helps it calm things down and start rebuilding. So you see, the fuel choice literally dictates its job.
Okay, so that's one direction of traffic. Now let's flip it around and look at the other side of the street. In Section 3, we're going to see how the fight steals energy, how the immune system can actually take control of your body's entire supply chain. Okay, so here's how it goes down. When you have an infection, your immune cells release these inflammatory signals called cytokines. One of these, called TNF-alpha, basically acts like a blocker on your insulin receptors, and what that means is glucose can't get into your muscle and fat cells to be stored. So what happens? Well, your blood sugar goes up, creating this big, easily accessible pool of energy for all those hungry immune cells.
Now, for a short-term crisis, this is an absolutely brilliant strategy. It makes sure your defenders have all the fuel they could possibly need. But what happens when that state of emergency never really ends? What if it just becomes this chronic low-grade war? Well, that's when this brilliant tactic turns into a long-term disaster.
And that right there leads us directly into our next section, when the system breaks and how it's undeniably linked to chronic disease.
So to really get this breakdown, we have to completely rethink what fat tissue is. It is not just some passive storage unit for extra calories. No, it's a highly active organ. It's like a central command post in this whole immunometabolic axis, constantly sending out its own signals, some that stir up inflammation and others that calm it down.
This is probably the single most important takeaway. Obesity isn't just a storage problem.
It's a state of constant, low-grade immune activation. What's happening is the system is just being overwhelmed by a nutrient overload, and it gets stuck in that emergency mode we talked about, just pumping out inflammatory signals all the time.
And the consequences of this chronic activation? Well, they're the very diseases we asked about at the start of all this. The constant inflammatory signals lead to long-term insulin resistance, which eventually becomes type 2 diabetes. This inflammation also drives the processes that lead to cardiovascular disease and atherosclerosis, the hardening of the arteries. It all connects right back.
But here's the good news. Understanding this system doesn't just explain the problem, it actually points us toward the solution. So that brings us to a more hopeful chapter, Section 5, Hacking the Axis for Health, and the amazing new frontiers this opens up for treatment.
Check this out. It shows how things we already know are good for us actually work on this exact axis. The diabetes drug metformin, for instance, it directly targets a key nutrient sensor called AMPK, which helps regulate energy. Exercise actually improves the metabolic fitness of our immune cells, and calorie restriction, well, it directly tackles that nutrient overload problem, which in turn lowers chronic inflammation.
And here's the crucial point. We have levers we can pull. By targeting the metabolism side with diet or exercise, we can directly calm down the immune system. And by developing new drugs that target inflammation, we might actually be able to fix metabolic problems. You see, it's a two-way street for treatment too.
All right, let's bring this all home. What's the bottom line here? What are the most important things for you to remember from all of this?
Okay, number one, your metabolism and immune system are not separate things. They are one single integrated system. 2, the system is designed to protect you during short-term emergencies. 3, that amazing protective mechanism becomes destructive when it gets stuck in the on position by things like nutrient overload. And finally, number 4, understanding this axis is absolutely key to treating so many of our biggest modern health challenges.
And that leaves us with one last thought to chew on. If the food we eat and the way we move our bodies can so profoundly shape our body's defense systems, all the way down to a cellular level, what does that mean for the future of medicine? Are we maybe moving toward a time where a prescription for your diet could be just as powerful as a prescription for a pill? It's a pretty fascinating question to think about. Thanks so much for joining me for this explainer.